Okay students, so in the previous class we discussed about electrode concentration cell. So today we can discuss what is electrolyte concentration cell is all about. Electrolyte concentration cell. Electrolyte concentration cell. So as the name suggests, now here electrodes are same. We actually change in the concentration of an electrolyte. So change in concentration of electrolyte do make a EMF, and that is now we can find in this electrolyte concentration cell. So let us again now discuss the same electrode, that is hydrogen electrode we can discuss. Let us represent the electrode like this platinum hydrogen gas which is maintained at 1 bar pressure, and we making sure now in the two half cells the pressure of hydrogen is 1 bar, and HCl, that's a now electrolyte that we are using. Let the concentration be A1. Now remember it's aqueous, so aqueous, and the concentration is A1 and separated by a salt bridge, because now here first we discussing a electrolyte concentration without transference. That means now here there is no direct transfer of electrolyte takes place. Here we separating into two half cells, and there will be salt bridge will be there, so that now there is no real intermixing takes place. So here HCl with aqueous A1, which means A1 is a concentration of HCl. And let's take the another electrode, this time platinum with and H plus ion, aqueous A2 bar and H2, and hydrogen is the hydrogen gas which is maintained at 1 bar pressure, platinum. So this will be this is the way that you can represent this cell, the electrolyte concentration cell without transference, where now A2 concentration of A2 is greater than A1. So we actually have now what's the experimental setup here? Here platinum hydrogen electrode, that is our anode here, and here again another electrode. So here hydrogen gas maintained at 1 pressure and hydrogen gas maintained at 1 bar pressure. So in the two half cells we make sure the pressure of hydrogen is 1 bar, and here we dipped this hydrogen gas in a HCl solution of concentration A1, here HCl solution of concentration A2. So that is a different concentration of electrolyte, that is different here both in the both half cells. Okay, now let us write the anode and cathode reaction. Anode reaction is, at anode you will see the oxidation takes place. That means now H plus ion is converting into hydrogen. So let us now imagine half mole of hydrogen gas is forming with the release of electrons. So this is anode reaction for you, aqueous A1. And cathode reaction. Cathode reaction means now here H plus sorry, this anode means now reduction, anode means oxidation. So how you have to write is hydrogen of H2, hydrogen gas is converted into H plus 1 electron, where this is aqueous A1. So here H plus aqueous A2 plus 1 electron gives half H2. So this is the reaction where now half H2 gas is converted into H plus 1 electron. That is anode reaction for you. Hydrogen is now oxidized, and at cathode H plus ion is consumed, and hydrogen gas is forming, right? So this is the anode and cathode reaction for it. So overall reaction you can write electron will be cancelled, so it just looks like no H plus aqueous A2 is now transferred to H plus aqueous A1. So this is the way you can represent. So net effect, there is no real direct transfer of electrolyte takes place, plus, but it's just like look like the H plus ion is moving from higher concentration to lower concentration. So definitely the difference in concentration of electrolyte is the driving force for the generation of electricity. So that's the overall reaction for it. Now let us apply next equation. Let us apply next equation to find the EMF of the cell. How can you find? So always know EMF of the cell. You can write E cell, which is equal to E cathode minus E anode. Here electron potential of cathode, that is now on the right hand side, minus electron side on the left hand side, ER minus ER. So how can you write EMF? It is will be equal to E0 hydrogen H plus minus 2.303 RT by N. Number of electron involved in the reaction is 1, that we already seen. So it is 2.303 RT by F. Yeah, let it be log because we multiply by 2.303. So log. So let us start with now reduced concentration. Reduced now which will be H plus 2 hydrogen, right? So 1 bar pressure. So it will be 1 by A2 for now the cathode. It will be concentration of reduced is actually hydrogen and the concentration of oxidized is equal to A2. So instead of this now you can change, you can bring A2 to the upper side, so this sign will change. So let us write now log A2 by putting plus here, minus similarly similar kind of expression where now let it be plus E0 H2 bar H plus 2.303 RT by F log A1, because now here A1 is the concentration of the anode. So let it be, we can write like this, E0 H2 bar H plus 2.303 RT by F log A1. Okay, so now how can we write? Okay, now we can write now here E0. Remember, standard reduction potential of hydrogen is 0, so you doesn't even need to write, right, because this is 0 0 or it will cancel each other. So this is the case where 2.303 RT by F log A2 minus 2.303 RT by F log A1. So log A minus log B, log A by B, you can take 2.303 RT by F outside. So 2.303 RT by F log A2 minus log A1, so log A2 by A1. That will be the EM of the cell. You can write 2.303 RT by F log A2 by A1. Okay, so that's the EM of the cell for you. So you can see the concentration of A2 is greater, concentration of A1 is lesser, so E cell will be always positive because you have an expression 2.303 RT by F log A2 by A1. If you want to express in ln, it will be no RT by F ln A2 by A1. So for converting ln into log, we are multiplying 2.303. So that's the way you can represent. Right. So that's all about now the electrolyte concentration cell without transference. So let us have another similar type of cell. This time now we using zinc electrode. So let it be zinc solid Zn2 plus aqueous A1 dipped in a concentration, dipped in electrolytes, zinc sulfate or something, so separated by salt bridge, then Zn2 plus aqueous A2, Zn2 plus aqueous A2 bar Zn. So similar type of electrolyte concentration cell. So what will be the anode? Anode will be zinc is oxidized into Zn2 plus. At cathode Zn2 plus converted into Zn. So similar type of reaction where you can write like this. At anode Zn is converted into Zn2 plus 2 electron. At cathode it will be Zn2 plus 2 electron gives Zn. So here it is A1, here it will be A2. So overall reaction you can write similarly. Zn2 plus aqueous A2 gives Zn2 plus aqueous A1. So this is the way you can represent the overall reaction. Now if you write the EMF of the cell similar like this, so instead of hydrogen it will be zinc. So you can represent E Zn bar Zn2 plus 2.303 RT log A2 minus E0 Zn bar Zn2 plus 2.303 RT by F log A1. So similar type of expression for EMF of the cell. So this and this will cancel. Standard electropotential of zinc, which is same electrode we have taken, so it will be 0. So net reaction will be like these two cancel means 2.303 RT log A2 minus log A1. So similar expression. So E cell will be equal to 2.303 RT by F log A2 by A1. So generally you can represent two electrolyte concentration cell without transference where A2 having higher concentration, A1 having lower concentration. The EM of the cell will be 2.303 RT by F log A2 by A1. Okay, so let us continue. Now we can express the same equation in terms of activity and activity coefficient. So we know what is activity is all about. Concentration you can express in terms of gamma m, where m is the modality and gamma is the activity coefficient. So A2 you can write like this, gamma 2 m2, and A1 you can represent gamma 1 m1. So let us apply this this in the above equation E cell, which is equal to 2.303 RT by 2.303 RT by F RT by F log log A2 instead of A2 gamma 2 M2 divided by gamma 1 M1. So this will be the equation that you can remember for EM of the cell if activity coefficient and molality is given. So we can apply E cell will be equal to 2.303 RT by NF log M2 gamma 2 divided by M1 gamma 1. So that's all about electrolyte concentration cell without transference. Now let us discuss the important one, electrolyte concentration cell with transference. With transference. So this is the case where now here electrodes are same, but there is a direct transfer of electrolyte takes place through the junction. Okay, two liquids are two half cells are separated by a junction where now the electrolytes are allowed to transfer each other. So this is now an equation that you can remember. Let us start with the same electrode. So here platinum, hydrogen gas, 1 bar pressure, HCl, aqueous A1, this time separated by another solution where no, it is concentration is A2, where the electrolytes are allowed to mix each other. They can move from one to other. 1 bar pressure platinum. So this is the way you can represent the electrolyte concentration cell, where two electrolytes are there with the concentration A1 and A2, and here in the junction which separate the two solutions where the ions are allowed to move. So simply the cell reaction will be exactly same that we saw at anode. Hydrogen gas will be converted into H plus. Similarly, H plus ion converting into hydrogen. Here aqueous A2. So overall reaction will be similar like this, where now H plus ion aqueous A2 is directly transferred to aqueous A1, where now concentration of A2 is greater than concentration of A1. So EMF will be generated this time by direct transfer of electrolyte from higher concentration to lower concentration. So let us derive an expression for this. Keep remember this equation. Now you have to consider that now here yes, H plus ion are moving. So let us have a calculation how much now it is. What is the concentration of H plus ion that is moving? Let us think in that way. Okay, let us imagine here at anode we saw H plus ion concentration is increasing. At cathode the H plus ion concentration decreases because at anode H plus ion is converting into hydrogen, where at cathode no hydrogen is converted into H plus ion. So in the left hand electrode you will see H plus ion concentration increases. In the right hand electrode you see H plus ion concentration decreases. So with respect to that, we know we are taking HCl solution. So one thing you can imagine, now H plus ion will be moving from left to right, and at the same time you will see at the right hand electrode H plus ion concentration decrease means now Cl minus concentration will be higher there. So chloride ion can move from right to left. So let the concentration of Cl minus ion that is moving from right to left. Let the concentration we represent T minus Cl minus ion is moving from right to left. That you can imagine it will be T minus Cl minus ion A2 is moving from right to left. Concentration A2 to A1. Similarly, T minus Cl minus A2 transferring from higher concentration T2 to T1, because they are now at anode H plus ion concentration is higher. So you will expect a moving from H plus ion to A1 to A2. Similarly, at the same time, as chloride concentration is higher at cathode at the right hand side, so it will move from So Cl minus I will move from A2 to A1. What is T minus P minus? It is a transport number of chloride ion. So a T minus gram equivalent of Cl minus will be transferring from A2 to A1. That part now I have written here. Similarly, now you will see T plus H plus ion will be moved from A1 to A2, but now this time you can represent T plus T minus will be always equal to 1. Summation of transport number equal to 1. So T plus will be what? T plus is equal to 1 minus T minus. So let us know, you imagine T plus H plus ion are moving from A1 to A2, or you can represent 1 minus T minus H plus. 1 minus T minus H plus are moving from A1 to 1 minus T minus H plus are moving from A1 to A2. So that's the way you can represent this. A1 to A2. So now let us write the overall reaction. Let it be 1, let it be 2, let it be 3. So these are the three processes that take place in the cell electrolyte concentration cell with transference. No? So let's sum the left hand side and right hand side to get the overall reaction. So here I am considering this as well. So overall reaction will be, no, overall reaction will be H plus aqueous A2 plus this T minus Cl minus A2 plus 1 minus T minus H plus A1 gives H plus aqueous A1 plus T minus Cl minus T minus Cl minus A1 plus 1 minus T minus H plus A2 plus, so we return T minus Cl minus A1 plus 1 minus T minus H plus A2. So that is the overall reaction for you. We just sum the left hand side and right hand side. That's only we did. So now let us expand this part. 1 minus T minus into H plus. Now you can multiply. So 1 into H plus minus T minus H plus. So let us now expand it. So it will be H plus aqueous A2 H plus aqueous A2 plus T minus Cl minus A2 plus 1 into H plus, that is equal to H plus A1 minus T minus, I just now cross multiplying, T minus H plus A1 gives H plus aqueous A1 plus T minus Cl minus A1 plus H plus A2 minus T minus H plus A2 minus T minus H plus A2. So if some common term is there, that you can cancel H plus aqueous A2. H plus aqueous A2. Here also H plus aqueous A2 is there, that you can cancel. Okay. So let us write what is left. So here T minus H plus A2 here, and here T minus Cl minus A1 is there, right? So let's bring A2 to same side. So T minus Cl minus A2 and what is A2 here? Here T minus H plus A2 is there. So let's bring A2 together. So this is minus means when it comes here it will be plus. So we can write that first. So it will be T minus H plus A2 plus, I bring this side means this become plus, T minus S plus A2 plus T minus Cl minus A2. So I bring the A2 on the left hand side and bring now A1 on the right hand side. Here T minus S plus A1 is there. When it's come to this side it will be positive. So it will be T minus H plus A1 plus T minus Cl minus A1. So the equation has been simplified like this. T minus H plus A2 plus T minus Cl minus A2 gives T minus H plus A1 plus T minus Cl minus A1. All others will be cancelled. H plus aqueous A1, H plus aqueous A1 will be cancelled. All other will be cancelled. Everything what is left, T minus H plus A2 plus T minus Cl minus A2 gives T minus H plus A1 plus T minus Cl minus A1. So the equation has been simplified like this. Now let us write the EM of the cell. We got the overall reaction including the transport number, everything. So let's write the EM of the cell. EM of the cell you can write E cell will be equal to, now you can imagine E cell will be equal to E cathode minus E anode. So here it will be just like, now you can write like this, T minus H plus Cl, you can write HCl A2 gives T minus HCl A1. So it just look like now the electrolyte transferring from A2 to A1. Now let us write the EM of the cell. E cell will be equal to E0 cell minus 2.303 RT by F log A1 raised to T minus divided by A2 raised to T minus. So let us represent this. So it will be equal to minus 2.303 RT by F log here not T minus is a stoichiometry, so that will come up. So A1 raised to T minus A1 raised to T minus divided by log A2 raised to T minus. So we are writing the inverse equation for this final reaction. T minus HClA2 gives T minus HClA1. So here now let's write A1 raised to T minus divided by A2 raised to T minus. So log A raised to something, now it will be always equal to, this will come to this side. So we can write this part like this, A1 by A2 raised to T minus. So here one thing you can remember, T minus will come to this side and log you can simplify this like this, log A1 by A2 raised to T minus. So final equation E cell will be equal to, let now negative sign is there, so negative sign can be reversed by changing this. So E cell is equal to 2.303 RT by F log A2 by A1. This time T minus will be coming here because T minus is the power that will come here. So T minus 2.303 RT by F log A2 by A1. So that will be our now final equation for the EM of the cell with the with transference. Electrolyte concentration cell with transference. T minus 2.303 RT by F log A2 by A1, where A2 concentration is higher than A1. So that is the electrolyte concentration cell for you. Similarly, you can express in terms of no activity coefficient. That also you can do. Where now A2 will be equal to gamma to M2, and here now activity of HCl we are talking about. So activity now will be always equal to activity of H plus into activity of Cl minus. So this is the way you can represent. So that means now A is equal to gamma M into A is equal to gamma M for H plus and Cl minus. So net effect now, the if you express the E cell activity in terms of S plus into Cl minus, it will be like just like gamma M into gamma M, where now gamma 2 M2 into gamma 2 gamma 1 M1. Sorry, it will now be talking about now gamma 2 M2 into gamma 2 M2, where no, this is one for H plus ion, other for Cl minus ion. So you can represent, it will be T minus 2.303 RT by F log. So instead of A2 you can write, so it will be M2 gamma 2 square divided by M1 gamma 1 square. Okay, so you can write like this. What we have done, we express the activity of HCl. Activity of HCl will be equal to activity of H plus into activity of Cl minus. So activity of H plus will be gamma 2 M2 for a electrolyte A2. So gamma 2 M2 into gamma 2 M2. So M2 gamma 2 whole square divided by M1 gamma 1 whole square. So you can write T minus 2.303 RT by F log. Now you can write M2 gamma 2 divided by M1 gamma 1 whole square. So 2 will come here. So final equation you can write like this. It will be 2 into 2 minus into 2.303 RT by F log M2 gamma 2 divided by M1 gamma 1. So that is the final equation. 2 into 2.303 RT by F log M2 gamma 2 divided by M1 gamma 1. So you can practice yourself. So thanks for listening to this class. Let us discuss in the next class. Thank you.